From thousands of years ago, when ancient civilizations named the constellations, to the 17th century when Galileo first pointed his telescope toward the sky, the question about the extent of the cosmos has always occupied the human mind. In the 20th century, with Edwin Hubble's discovery of the universe's expansion and later with massive mapping projects like the Sloan Digital Sky Survey, we began to understand the cosmic web. But when we reached the year 2013, this exploration brought us to a massive wall whose grandeur was difficult for everyone to comprehend. In the wondrous world of the cosmos, where scales go far beyond our everyday imaginations, the largest known structure to date is not a massive star or a gigantic black hole, but a vast chain of galaxies called the Hercules Corona Borealis Great Wall. This structure, sometimes abbreviated as HER-CRBGW, is a symbol of the universe's grandeur and has challenged scientists to reconsider their understanding of the world. But to truly grasp this immensity, let's start from familiar and small scales, gradually moving toward astronomical dimensions. This approach not only helps us better sense the scale, but also prepares us for encountering this cosmic giant. First, let's start from a point we're all familiar with: the distance from Earth to the Sun. This distance is only about 150 million kilometers, which is equivalent to roughly 8 light minutes. That means the light emitted from the Sun takes 8 minutes to reach Earth. This is just a small step in the endless path of the cosmos. Now, let's scale up. The Milky Way galaxy, home to our Sun and planet, has a diameter of at least about 100,000 light-years. The Milky Way can be likened to a gigantic disk filled with stars, with over 100 billion stars scattered throughout, and our Sun is just a tiny dot in one of its outer arms. But galaxies don't exist alone. They tend to gather in groups called galaxy clusters. For example, our local group, which includes the Milky Way, the Andromeda Galaxy, and about 50 smaller galaxies, has dimensions of around 10 million light-years. This cluster acts like a small neighborhood in a vast cosmic city where gravity binds the galaxies together. Let's take the next step and reach superclusters. Superclusters are even vaster collections of galaxy clusters. The Laniakea supercluster, of which the Milky Way is a part, spans about 520 million light-years and includes thousands of galaxy clusters. Laniakea can be likened to a metropolis on the cosmic map, with gravitational flows connecting clusters like bustling streets. But the universe is even more layered than this. At larger scales, structures like filaments or galactic walls emerge, linking superclusters together. For instance, the Sloan Great Wall has a length of about 1.4 billion light-years and looks like a long highway filled with galaxy clusters. These structures are part of the cosmic web, where matter in the universe is distributed in a network, with vast empty spaces called voids between them. And now we reach the pinnacle of this journey: the Hercules Corona Borealis Great Wall, which, based on initial reports, has a length of about 10 billion light-years and may even be larger. Acts like a massive and voluminous chain of galaxies, Not just a thin line, but a complex filament encompassing clusters and superclusters. Inside this structure, it's estimated there are millions or even billions of galaxies, each containing trillions of stars, numbers that really challenge the mind. Interestingly, based on recent studies in 2025, some researchers have suggested that its actual size might reach up to 15 billion light-years. But these estimates still need further confirmation and are part of ongoing scientific debates. The story of discovering this wall dates back to 2013, when a team of American and Hungarian astronomers, led by István Horváth from the National University of Public Service in Hungary, along with John Hakala and Zsolt Bagoli, analyzed data from space telescopes like SWIFT and Fermi. They didn't directly observe galaxies, but used an indirect method, analyzing gamma-ray bursts, GRBS. GRBs are extremely powerful energy explosions that often occur as a result of the death of massive stars or collisions between black holes and neutron stars. These bursts act like light signals in the darkness of the cosmos and can indicate regions with higher matter density where star formation is more active. The scientists analyzed 283 GRBs and noticed that 19 of them were concentrated in a specific area of the sky, with redshifts between 1.6 and 2.1. Redshift indicates distance. The light from these structures is stretched and reddened due to the universe's expansion, showing a distance of about 10 billion light-years. According to the cosmological principle, the universe on large scales should be uniform and homogeneous, and structures shouldn't be larger than about 1.2 billion light-years. This is a theoretical expectation based on standard models. The existence of such a structure suggests that the universe might be more inhomogeneous on very large scales than we thought, like finding a massive mountain range in the midst of a uniform fog. Let's discuss how this wall formed. After the Big Bang, the universe was filled with small fluctuations in matter density. Over 13.8 billion years, these fluctuations, under the influence of gravity, turned into clusters and superclusters. Simulation models show that dark matter could play a key role in connecting these structures, like an invisible glue binding clusters together. However, this role is not yet definitive, and models have limitations. The wall might not be a single integrated structure, but a collection of smaller clusters that appear connected from our view due to high redshift that makes direct observation difficult. Telescopes like the James Webb Space Telescope, with their infrared capabilities, will collect fresh data and may reveal similar structures. Missions like Euclid from the European Space Agency or the Vera C. Rubin Observatory, which focus on three-dimensional mapping of the universe, could provide good information about this wall. There are even proposals for the Theseus mission to observe GRBs with greater precision. Such discoveries expand the horizons of our understanding of the cosmos, and perhaps in the deeper reaches, even more immense structures await discovery. Thank you for your attention.